Can we start?
राइस सर स्टार्ट कर सकते हैं।
सर स्टार्ट कर सकते हैं।
ठीक।
मेरी आवाज क्लियर आ रही है?
हाँ सर, इस
ओके, तो ठीक है, आप स्टार्ट कर रहे हैं पहले या मैं शुरू करूं?
हाँ मैं
नहीं चलिए।
एक बार इंट्रोड्यूस कर देता हूँ मैं।
ओके,
Good evening, all of you. Once again, welcome to all in this FDP program. Today we have a distinguished person with us, Rajesh Gupta ji. So I would like to introduce him first of all. Dr. Rajesh Gupta is an assistant works manager at IOFS Group, and he is a gazetted officer at the Ordnance Factory Institute of Learning, Kamaria, Jabalpur. It's a unit of Munition India Limited under the Ministry of Defense. With over 20 years of experience, he has spent more than 12 years in industrial production, maintenance, and research and development, and 8 years in academia, where he has designed and conducted specialized training for Group B officers of the OFB organization. He has also led workshops, webinars, and conferences for gazetted and non-gazetted officers, along with specialized civil trade courses for technical students in defense production technologies. Dr. Gupta is a member of prestigious organizations like the Indian National Science Congress, IIPM, FIA, that is Institute of Engineers, and IAE-NG. He holds 4 patents and he has published multiple research papers in national and international conferences. His expertise includes industrial production, administration, defense manufacturing, supply, chain optimization, industrial engineering, and maintenance management. So this is a brief introduction to our distinguished guest, and I would like to invite him for this session. So welcome, sir.
thank you, Dr. Vivek, and thank you, Dr. Manoj, for calling me as a guest faculty in the Extreme program that is organized under the umbrella of the ATAL FDP programs by IPS College. Thanks, all of you, because this is a collective commitment to academic excellence, innovation, and continuous evolution for teaching and research methodology. I'm involved in the defense manufacturing sector from a very long year, and I am aware about the latest technology that we are facing and we are incorporating in our defense manufacturing. So today's topic is very I say it is very emerging topic to use the digital twin in micro machining, because micro machining is also a very research views or research overviews topic which have a lot of potential to be developed in different sectors and different area. This faculty development program is serve a vital platform to knowledge exchange, skill enhancements, and professional growth to all the participants, in my view. In today's session, we delve into digital twin technology in micromachining, a cutting-edge area that bridges the gap between physical and digital systems, enabling real-time monitoring, optimization, and predictive decision-making. So, with your permission, can I share the PPT?
Yes, sir. Yes, sir. Please share.
One minute. Is it visible to you?
Yes, sir, it's visible.
Okay. Well, what is the problem? Yes. Okay. So are you getting this screen now?
Yes, sir.
Okay. So first, I will tell you about something about the micro machining. What is a micro machining? A micro machining is a technology that revolutionized various industries by enabling the creation of incredible precise and complex miniature components that are used in the various industries like medical, like defense, like space, and others area. So how we define the micro machining? What is it and why it is important? So micro machining that involve the creation of very small components. That components have the extremely fine details and have the high precision. This technology allows for the manipulation of materials at a microscopic level, that opening up the possibilities for advanced and miniaturizing the devices that have the bulk and very big in the size. We can compress it in a miniature. Why it is important? Because there's a gap between the traditional machines. We are not manufacturing very small and complex part in the traditional machining methods. So micro machines give a very important solutions that produce the nano scale manufacturing and enable the production of components with having the feature of micrometers and micro levels. So these micro components find the application in various fields. What are the advantages if we go for the micro machining? Number one, we get the highest precision at that level. So micro machining that deliver incredible precision in manufacturing, enabling the creation of component with tight tolerance and complex geometries. It promote the miniaturization, the technology that allow with the creation of incredible small components that is not possible with the other traditional types of manufacturing facilities. It lead for development to compact and the powerful devices. Efficiency. It also focus on the efficiency of the machining process. Micro machining process often the highly efficiency because it have the controlled environment where we can achieve the highest efficiency during the manufacturing or during the manufacturing process. It reduces the material wastage and optimizing production time. Sometime in the defense manufacturing, we are using that metals have the highest cost, highest toughness, highest hardness that are very difficult to machine. But using the micro machining, we reduce the wastage and we uh, get the efficiency during the machining process. The versatility of the micro machining process. The micro machining is versatile and can be applied to a wide range of materials, from metals and polymer to ceramics and semiconductor. Are you hearing my voice now?
Yes, sir. Yes, sir.
Okay. So when we talking about the micro machining, it is very important to talk about the challenges we are facing in the micro machining processes or micro machining adaptability during the manufacturing industries. Because you heard the industry 4.0 and industry 5.0. I think everybody heard. Yes or no, sir? Hello? Hello?
Yes.
Hello?
Yes. Yes, sir.
Yes. Okay. So industry 4.0 environment, when we're talking about, we have a incremental and changes that incorporate in the traditional machinings so that we can go for the real-time monitoring, we can improve the efficiency, we can improve the safety, we can monitor and line up the machines with communicable devices so that each other can control, integrated their functions. So when we're talking about the micro machining in that era, in Industry 4.0, Industry 5.0, we need precise control over the machining process. So maintaining the high level of precision and accuracy during the machining process is very critical, as many error can significantly impact the final product. If there is an error in any part, it impacts all the dimensions and all the related dimensions that deteriorate your final product, reject your final job. Tooling and equipment, the second point, that is very important challenge because micro machining is required specialized and customized tooling and equipment by machine itself. Each machine has the different configuration that need the customized requirement of tooling. So, which is very
Mr. Rai,
expensive. Yes.
Mr. Rai, sorry for the interruption.
Yeah.
Can you your review in PPT mode, full slide, full mode, mein?
Okay. Okay.
Yes.
Is it okay?
It is okay.
Okay.
Thank you.
Okay. So I'm talking about the second points, that is tooling and equipments. So each specialized machine need customized tooling for the machining process, which is very expensive, and that required also the expertise of the operators, which is working on this machine. So you need the special type of training, you have this special type of maintenance, you need the special types of maintenance activities and training. It very costly. Then third is material properties. The properties of material that is using in micro machining have the micro scale property observation, because some material is not showing the property that is in traditional machining and in the micro machining process. So that impact the significantly different from the bulk work counterpart, posing the challenges in machining and surface finish of these parted. So we have to take consideration of these material properties also during the choosing of micro machining process. Fourth is quality assurance. The quality assurance is very important part in the defense manufacturing. In every manufacturing, we say, without quality checking, and nobody can get the final right product at right time. So the inspection and ensuring the quality of micro machine part is very essential because it consists of very small size particles and integrated features, which you have to measure in each and every respect of drawings, dimensions, specification, characteristic that is required for the special techniques, tools, and equipment to check their quality assurance. So we discuss about some micro machining technique here, like laser machining. Laser machining is a highly precise and versatile machine technique that uses a focused laser beam to remove the material. The another one is electron beam machining, that is also employed a focused electron beam that melt or vaporize the material. It enables the creation of integrated micro features. The another one is ion beam machining. It also uses the beam of focused ions that erode the material, and it allows the creation of integrated microstructure in the work is material. Another one is micro electro discharge machining, that is called the micro EDM. It is also a very important process. If you search in the last 5 years, there is very much research paper is published in micro EDM. It uses a series of electrical discharge to erode material, creating precise micro features. It is well suited for the machining hard and conductive materials. So these are some example of micro machining techniques which very frequently uses for micro machining. Now we shift to the application of micro machining. So there are some fields where the very we say they are using these micro machining techniques process during their work, like medical devices. The micro machining enable the production of miniature medical implants, microsurgical tools, and other advanced medical devices that can be use a miniature parts that fit in your body and using for the medical treatment, medical attentions, here like your veins, artificial veins. These are creation. Microelectronics. The micro machining is also essential for the manufacture of microchips, sensors, and other components found in electronics devices. Optical devices. The micromachining is also used to produce the micro lenses, grating, and other optical components that is used in various applications for microscopes to cameras, that is used in very vast field in defense also, in space also, in other area also. Aerospace. Micromachining is used to create lightweight and high performance component for the aircraft, satellites, and other aerospace application where the weight and cost is very much factor that is incorporated during the manufacturing. Automotive. Automotive is also micromachining used to produce the fuel injection, sensors, and other components for the modern vehicles. Now, the material. There is no limit of the material, but we have to consider using their micro material properties before machining to the micro machining. Like if we talk about the metals, that include the silicons, titanium, golds, and others that often used to their strength, durability, and electrical conductivities. Second is polymers. Polymers are also used to their for flexibility, their easy of processing, and biocompatibility, making suitable for the various medical and optical applications. Ceramics. Ceramics are known for their hardness, their wear resistance, and their high temperature stability, making them suitable for the demanding applications and creating the miniature components level they fit for the use. So if we're talking about the future of micro machining, so micro machining future is depend on first in advanced material. Whenever we use the advanced material with tailored properties, which enable the creation of even more sophisticated micro components. So the advancement of material is needed for the future. Integration. Micro machining also play a critical role or crucial role in development of integrated systems, combining multiple micro components into compact multifunctional devices. The third one is nanotechnology. The integration of nanotechnology with micro machining will also lead to the creation of even smaller and more complex micro components that are using nowadays in the real life. Also, you say all the things are going to the compact. Their size is going to reduce by using the nanotechnology and creating the small parts, but by combining all the functions in a one shot of piece, it is very critical. And for that, we are using the micro machining that can be combined. So if we say about the defense, because I am involved in the defense manufacturing, so I will explore, discuss 2-3 cases that uses in defense manufacturing by application micro machining processes. So the revolutionize of defense. Discover the impact of micro machining in defense industries. So if we go about the advantage in defense applications, defense is first is enhance the performance. How it is enhance the performance? Because micro machine component offer the increased precision, reduce the weight. That is a main problem in weapons we are using. Weapons our forces are used. So reduce the weight with the strength, because we cannot compromise with the strength of our ammunition, our ordnance. So using the micro machine component, we can offer the reduced weight, we can offer the enhanced durability of the components, we can enhance the durability of the product, leading the improved performance in defense systems also. Miniaturization. The micro machining enables the creation of compact and lightweight components that is crucial for reducing the size and weight of weapons. Sensors that are used in that weapons and other defense system, like your visual system, like your target fixing system, like your recoil system and other systems. The third is increase the functionality. Micro machining also allow the integration of multiple functionality into a single component that enhance the capability of the defense system. So if I discuss about the micro scale component for weapon system, we can use in precision gears, that is use the micro machine gears that have the high accuracy and efficiency in weapon system that enable a smoother operation and increase the performance of our weapons. The second is miniature ball bearing. The micro machining bearing provide low friction, high durability in weapon system that also reducing the wear and tear while enhancing the accuracy of ball bearing where it is used. The micro actuators, that is also required because in a weapon system there is a number of the components which actuate by one go. So each and every function has their important role, have their cruciality, because that's why in the defense manufacturing, the safety is the first things that we consider by using the quality XWAP. So the micro actuator that enable the precise control and movement in weapon system, it enhances the targeting accuracy and overall performance of the weapon. The micro optics sensor for surveillance and targeting. Like in previous slides, we have discussed about the optical applications. So micro optics also used in the mirrors, in the cameras, in the sensors, in the lenses, micro machines lenses, with the advanced surveillance systems that enable the high resolution imaging, improve the target identification at the area where it is very difficult to identify the target. Microsensors. Developing microsensor, including the pressure sensor, temperature sensor, and accelerometers. It provides the real-time data for critical decision-making and defense applications. Integrated systems. Micromachining also enables the integration of optics and sensor into a compact and portable system that enhancing the battlefield awareness and targeting capabilities. Now, the microfluidic for advanced technology is also done by the micro machining methods, because microfluidic is also required in various places. Like microfluidic devices use microchannels, chambers that manipulate fluids in a microscopic level. It enables the precise control. It enables the analysis not on defense manufacturing application, in various other applications also, like biodetection. Microfluidic device used in biodetection system, enabling the rapid and accurate identification of biological threats, such as chemical agents or pathogens. Drug delivery. It is also used to control the drug delivery in battlefield medicine, ensuring targeted treatments and improve the outcomes. What are the challenges and limitations in defense or in any other industries when we go for the micro machinings. First is complexity. You have to analyze the micro machining that required advanced engineering skills and specialized required equipments that is required by you required is not or not required, because making it a very complex and challenging processes. You have specialized trained operator, you have the specialized maintenance, you have you should have a specialized tool, you should have the specialized quality checking procedure systems. So complexity you have to control, or it's encircle the complexity of the system. Second is material constraints. Not all the material are suitable for micro machining, so you have to identify and select where you have to go and which material you are using in which component you are applying this micro machining process, that limiting the range of applications and type of components that can be fabricated. The third and very important things for any industry is the cost analysis, because micro machining process can be costly, especially for the large scale production. So that is why cost analysis to be done before going for the micro machining application or micro machining application in your industry. So we discuss about some future trend of an innovation in the micro machining. The nanotechnology is very important future technology that is integrating with micro machining, because it is expected to lead that further miniaturization is possible only if we integrated the micro machining process to the nanotechnology that enhance the functionality also in defense applications and other areas also. Artificial intelligence. Artificial intelligence that control, monitor, coordinated all the process, all the system in the real time monitoring or real-time observations that create a visual image. So the AI-powered micro machining system automate and optimize the process. It leading to improve efficiency, it reduce the cost also. Additive manufacturing, using the combining or integrating micro machining with additive manufacturing allow to create a complex and customized product or components that is not manufactured by any available traditional manufacturing methods. Now, after getting the overview of micro machining process, we discuss about the digital twin technology. What is the digital twin? Are you getting my voice?
Yes, sir.
Okay. So we discuss about the application digital twin. First, we understand the digital twin, and then we go for the application of digital twin in micro machine. So what is a digital twin? A digital technology is a powerful tool that rapidly transforming industries that allow visual representation of the real world object, real world system, and real world process. This representation explore the key concept, applications, and features. So, digital twin is a virtual representation of a physical assets, process, or system that mirrors in its real-time counterpart. What are the key features? If we're talking about so digital twin are real-time, dynamic, and data-driven. Digital twin collect and analyze data from the sensors, database, and other sources to create a comprehensive digital model. And that digital model is making your physical assets, process, or system in a digital twin. So, how a digital twin system or digital twin model is work? The digital twin system, as we discussed, it is a virtual replica of a physical world or physical process, physical assets. First, we have a data collection system to create any process or system in a digital twin network or convert in digital twin. So data collection is through the sensors, data collection through the IoT devices, or database capture the real-time data from the physical assets. Once you have the database or data collection, you complete your data collection, we have go for the data analysis. The data analysis, in data analysis process, the collected data is analyzed using various type of algorithm, various type of machine learning methods, and we generate insight and prediction models by using the data analysis. After doing these predictions and insight, we make a virtual model. So a virtual model is a virtual representation of the physical assets created based on the data that we have collected, based on the analysis that we have done, based on update data that after developing in the model, we have checking through the real-time methods. So updated data on the analyzed data. The next thing is simulation and prediction. Once this virtual model is built up, we use this build-up digital twin model to simulate the various scenarios and various environment to make the prediction about the physical assets behavior, how this physical asset behavior. Like, for example, I have taken a CNC machine. I have created a virtual model of the CNC machine by using their feed, depth of cut, speed, accelerometers, then other cutting forces and temperature, noise, vibration. Okay. After after collection the data, I have done the data analysis that what speed, at what RPM, how the machine is behave, at what feed depth of cut, how the machine is behave. And after changing in the machine, I have checked this model, is the result is correct or not. Once my model is built up, I can analyze the changes in my machine by changing in the simulation. I have seen the changes in my virtual model without doing any physical changes in my machine. It is clear?
Yes, sir.
Okay. So now we discuss about the key component of a digital twin. So key components consist sensor for data acquisition system. Sensors and data acquisition collect the real-time data from the physical assets that is crucial for creating an accurate to update digital twin. The second important is data processing and analytics. Data analysis and visualization are essential for extracting meaningful insight from the collected data. Here is a very important point is meaningful insight, because data is having raw data. From the raw data, you have to extract your meaningful insight that is related to your digital twin systems. Next is virtual model. So this is the core component of digital twin. Without virtual model, you cannot create any digital twin system. It provides a comprehensive representation of your physical asset. Fourth is user interface and visualization. Once you created all the things, but if user interface is not good, you cannot visualize the data. It is not for use. It is no need to, we cannot analyze it further. So a user-friendly interface allowed stakeholder to assess and interact with digital twin, enabling the informed decision making. Many times, this visualization system is not in the one platform or one on the machines or one system. It has the multiple user for, so anybody can check at any place, maybe in factory level, maybe their head office level, maybe their corporate office level, maybe their manager level. Anybody can visualize the data, what is going on, what is happening in their system by using this. So now we move on the application of digital twin technology. So digital twin technology used for manufacturing, used for healthcare, used for energy sector, used for smart cities or smart applications, like optimizing production processes, For example, I will give a example of defense industries. The digital twin is also using when we are manufacturing some chemicals that is required for our making the ammunitions. So during the manufacturing, that chemical have the properties. We have to maintain a defined temperature, humidity to before filling or before manufacturing that ammunition. If the humidity is reduced or changes or temperature changes, the property of that chemical composition, we say in technical language chemical composition, because I cannot take any name of the explosive or any chemical in this open forum. So that chemical composition have the properties. If we changes the parameters that is specified in their process, it deteriorates their characteristic, and ultimate the ammunition will not give the desired result that is we needed. So that's why we have to monitor and control all the things. The second thing, important things in explosive or ammunition manufacturing, we have the limitation of the manpower. In a one building, we have the number of the building where the ammunition is manufacturing. So in a one building, have the limitation of the number of the persons, number of the materials. We have certain limitation. If I use the digital twin of that system at that room, I can analyze everything, that how much material is available, how many percent is available, what is going on, what are the temperature, what are the sensors, everything I can monitor in a system. Like previous example, CNC also, I can check all the process, how much speed is going on this, is how many components is manufactured, what are the cutting forces that presented, is tool is blunt or not, what are the tool life, I can predict the tool life also. So these things help me to optimize my production process. I can optimize my production system. I can reduce my downtime by analyzing all in preventive maintenance and predictive maintenance also, and enhancing the quality control also. Because if the machine is unable to assess the things, I can control the feed that occurred, feed, tool, pressure, cutting force also. So I can reduce all the parameters that deteriorate the quality of my components. In healthcare, personalized treatment planning, medical device simulations, or remote patient monitoring can also done by the digital twin. In energy, predictive maintenance of renewable energy systems and optimize the energy grids is done by the digital twin. For smart cities, if we say traffic management, resource optimization, and improving urban planning is done by the digital twin technology. Lot of changes is going on. Lot of systems are adopted to control these things to create, we say, the smart life implementation. Recently, lot of example is all around us. So the benefit of digital twins, benefit is first enhance the efficiency. The system optimize process, the system reduce time times, it improve resource allocation very well. That is not the well-worse done by the human or other things. It reduce the cost because you assess all the things by early detection of the problems. So you do the predictive maintenance, as I said earlier, and early detection of the problem that can save significant cost. You can also, if I say, predict the material requirement and the waste of material, you can also reduce by predicting or early detection. You can improve the safety also, because in digital twin, if any point, any place is look after that have some of the chance of incident or accident, you can remove immediately by giving the attention. So the simulation and risk assessment can identify potential hazards and it mitigate the risk also. It gives a better decision making because you have make a virtual representation of your physical assets. Whatever changes is needed, you can change in your virtual mode. You can get the desired results and you can apply on the physical system after analyze all the data. So digital twin provide real-time data and insight, enabling the data-driven decisions. Now, we are discussing about the digital twin benefits and other things, but it is also important we have to consider what are the challenges we face for adopting the digital twin technology and what are the limitations. The very much importance on any digital assets is data security and data privacy, because you have the sensitive data, you have all your data that can any hackers can hack your data and make a you say the complexity, so it can deteriorate your whole system if it is hacked your data. So protecting sensitive data collected from the physical assets is a very critical concern. So you have to ensure the data sure cyber security of your data. Cost of implementation, second important challenge, because developing and maintaining digital twin can be expensive. It required significant investments. Many of the organization is use these for their training purposes, so that the cost that involved in training that reduce by using the virtual system. Lack of standardization is also very important, a very prime problem that we faced, because the lack of industry-wide standards make it difficult to integrate different digital systems. We are not having the standard components. We have not the standard any. Each company have their specific customized components, component details. So we have to match it, and use it. So lack of standardization is also a big problem in this. Complexity of the modeling. Modeling is also create accurate and comprehensive digital twin that require the specialized skills and require the specialized expertise. That is also a very big challenge we faced by adopting digital twin system. What are the features of digital twin technology, if I say? So it is a digital twin poised a significant growth in the coming year. It advances using the artificial intelligence, machine learning, cloud computing with enhanced capability of digital twin. Integration of digital twin across the industries create the new possibilities that increase innovation, efficiency, and sustainability. For an example, I will give you an example of our industry. We manufacturing one components. That components is going after manufacturing offered to the quality inspections. Our quality inspection person will come, inspect all the part, it submit the report. In the report, this report is go to the planning section, then it go to our store section, because the final component is dispatched by the store. So that report once with material is go to a store, and that report also go to the planning section. After getting this material, store is making a place where it has to placed, and then it order call the transporter for the dispatch of this material. But where to dispatch, it decided by the planning section. This whole process is taking 2 to 3 days. But when I go in its digital twin environment, what happening? Once the quality person is come to checking these components or this product, this is connected through the sensor to the system that have the digital twin system, where it accept the part. When it accept the part, all the things is going to the store section and planning section. After accepting it, store is automatically created the space for this material storage. The planning is also giving the instruction to the store where it is to dispatch. Then store is called the transporter, and it is only 6-hour job, 5-hour job. It's a 1-day job. So the 3-day job can reduce in the 1-day job by using some other technology. This is one example I am giving. Now we come to the end part of our today's topic, that is the application of digital twin in micro machining. I think all the things are clear to you. अभी तक हम लोगों ने जो बात किया शायद इज ओके. हेलो.
Yes, it's okay.
Okay, you are getting numbers. Okay, so the transformative potential of digital twin in revolutionize the micro machining industries that we can explore here. So we have already discussed what is a digital twin and what is this. Uh, we discuss about this now. Okay. So when we're talking about the digital twin in manufacturing systems, how it is benefited us. So it improves the efficiency of our manufacturing system, manufacturing processes, manufacturing workout. So digital twin enable optimization of process by simulating various scenario and identify the area where the improvement is needed. Sometimes what happen, the work is going to repeat it. When you making a digital twin, you can customize, you can reorganize, you can rearrange your process, your machines, your operations, so it can improve your efficiency. It can improve your efficiency. It can also improve the optimize the your process, optimize the process. Then second is important thing is enhance the quality. When you're getting the real-time insight and monitor, the digital twin contribute in product quality and consistency. In nowadays, uh, we are using some online gauging system. That online gauging system is work is during the manufacturing itself. You can measure the quality parameters that is needed with or is assist is with this process. So that can also matter by the digital system. What is your requirement? What is the sensor is measuring? What is going on? Like I am doing the welding. During the welding itself, a camera is attached with the welding, robotics welding. The camera is taking the video or capture the image of that weld. So it is properly fill all the channel or not. It is compared with the digital twin system in the monitor. Whenever the deviation is occur, the system itself say that the height of 30 mm and the width of the 20 mm, there is a weld point where is a some slag is present. So you can identify through the system also. So it enhance the quality system. It reduces the downtime. When we go for the machine, we go for the predictive maintenance, we go for the condition-based maintenance, because predictive maintenance capability powered by digital twins help minimize downtime and ensure continuous operations. What are the challenges we are getting in manufacturing when we use the digital twin? First is extreme precision, because micro machining requires the unparalleled precision that is making it susceptible to minute error and variations. Tool wear and tear. Miniaturization amplifies the impact of tool wear, that frequent maintenance and adjustment is required. Complex geometry. You have to monitor this integrated geometry that involved in micro machining. So how you can create this digital twin model with the real-time model, it is a challenges in micro machining systems. So digital twin system for process optimization, how we can use, we can do the process simulation first. So digital twin enable the virtual simulation of micro machining process. These system or simulation allow engineers or the operators to experiment and optimize the parameters. Like I say, for example, in an EDM machine, we are using the Hello.
Yes, Mr. Rajesh, your voice not.
Are you getting my voice? My system is maybe our meeting is disconnected.
Yes, yes.
अभी मेरी आवाज आ रही है आपको?
हाँ सर, आ रही है, आपकी आवाज आ रही
Okay. PPT शो हो रहा है स्क्रीन पे?
Yes, sir. Okay, sir.
Okay, 1 minute. Okay, so I'm talking about the process simulation. So digital twin allow our virtual simulation of micro machining process. So we can calculating the changes, whatever the required to optimize the parameters. So we get the maximum MRR or something else, whatever we needed in this machine. Second thing is parameter tuning. So by analyzing simulation results, we can fine tune the process parameters to improve the precision, improve the efficiency, and getting the maximum output in various manufacturing processes. The third very important thing is real-time monitoring, because in some places we are not getting the uh, real-time output, what is going on in our process, what is happening. So through the digital twin, you can getting everything, and you can get a you can record a data also from the all your previous work. So you have the database also. So digital twin provide real-time insight into the process that allow the necessary adjustment, necessary intervention that is needed at any point of time. Now, the simulation and predictive maintenance, it is also a one part where we can use the digital twin. So for that, we need the sensor data. Sensor on micro machining equipments collect real-time data on their performance, on their condition. So their performance-based and condition-based data, we can collect it. Data analysis, digital twin analyze the sensor data that identify trends and pattern that indicate potential failure. In this data analysis system, I give you one case study. We have the 10 machine, or a very important machine that is very critical, that is allocated in different sections in our industry, our factories. What happened? We have connect all the data flow sensor of all the 10 machine. We are creating the digital system in a one user interface of all the 10 machine, because these machines are very critical machines. We have monitor of these machine using the golden parameters. That golden parameter we selected, we identify, and we making a digital twin condition based system using these golden parameters. Whenever any golden parameter is going to change, we identify where the deterioration is going on. Accordingly, we predict it, we correct it. So the breakdown is reduced. These are one case studies that we implement in our factories. So data analysis and predictive alerts. So as I told, once the condition of performance is changed, it gives an alert system. So digital system generate alert and recommendation for maintenance, preventing unexpected downtime. So integrating of digital twin with micro machining. What is the needed? First is hardware integration. What are the hardwares we need? Sensors, actuators, controllers that are very integrated into the micro machining equipments. The second important thing is data acquisition. Once the hardware integrated, you have to acquire the data from these sensors, hardwares, and whatever the electronic system, electronics software you are using. So the real-time data from the machine is captured. This data is transmitted through the digital twin systems, then simulation and analysis. This digital twin simulate the process, analyze the data, it provides the insight of optimization. And the last is feedback and control. The digital twin send feedback to the machine, enabling the real-time adjustment and control. Because once you make the data, it maybe changes because of the number of the parameters is involved, number of the conditions is applied. So you have to correct it using your feedback system. Whenever there is a change or correction is needed, you can do and change and correct your model so that the next time you get the desired result, or so that it give you the correct and precise control. So we come on the conclusion part of this future outlook and conclusion. So digital twin technology hold a tremendous potential to advance micro machining, enhancing potential of enhancing efficiency, quality, and sustainability. As technology evolve, we can expect further integration of digital twin with AI and robotics, leading to even greater breakthroughs. So, digital twin technology is transforming micromachining by using the real-time monitoring, adaptive controls, and predictive maintenance. Despite challenges, advances will continue to enhance its capability, making micromachining more precise, more efficient, and more intelligent. So, this is from my side. Now is time for open discussion and your question. I welcome your questions. Hello.
Yes, sir.
Anybody wants to ask the question?
If anybody wants to ask question, please ask.
Sir, I have one question. Sir, what kind of real-time data is fed into micro machining digital twin?
Okay. Mr. Prem, the real-time data is capturing from the machine or whatever the physical system you are selecting for making digital twin. For example, you are selecting one CNC machine. You want. Hello.
Hello.
Are you getting my voice?
Yes, yes.
Are you getting? Yes. So you collect whatever you want. If you control the machine machining parameters for maintenance purpose, you can take the cutting forces, you can take the spindle bearing parameters, you can take the noise parameter, and you can monitor and create it. So whenever you make any change in these things, on the based on the data, you can check or you can simulate these changes in your system also. So first you collect the data, okay, inputs. Second, your output. Then you create the algorithm. You create the model using the machine learning or AI generated models. After you test it, then take the feedback and then you make it virtual digital twin of this CNC machine. Clear?
Okay, sir. Thank you, sir.
Is there anybody else who wants to ask questions?
Hello, good evening, madam.
Good evening, sir.
Rajesh sir, I just want to ask a questions. Wait, wait, sir. I think repetition is happening.
Hello. Hello. Right, sir, am I audible? Hello.
Yes.
May I? Sir, actually, I just want to ask questions regarding this micro machining. Actually, this is the part of 4.0 automation. What happened? Being a mechanical engineer, we feel some sort of programming hurdles. Means, suppose we have to make our own program. Then in CNC, we use G code, M code. But these machining, what kind of language these machining are basically used to? What kind of programming skill we should learn so that we can make more friendly these machines?
Mr. Rajesh, you are asking
Sir.
about the machining operability systems that's provided by the OEM, like G code, M code, how they are controlling their machines. Okay. So if I'm talking about the digital, okay, every machines, whatever in as a CNC or something else, they are using their own coding language. Okay, in that coding language, they give trained to the operator when they supply the OEM. Okay, so when we go for the automation or Industry 4.0, that is another part of the
Right, sir.
modernization of industry. Okay, when we're talking about the digital twin, okay, so digital twin is the replica of this system. There is no connection between the coding of this machine with the G code because you are controlling the parameters. You are making a replica of this conditioning parameters, specification, characteristic, whatever you are want to create a own changes. Okay. So digital twin is different and this coding is totally different part. Is it okay?
Right, sir. Right. Thank you. Okay, sir. Thank you.
Welcome. Any other?
I think Mr. Akash Tomar wants to ask question.
Yeah. Sir, what are the potential
Akash Tomar.
risks? What are the potential risks relying on digital twins, sir?
As I discuss in my slides, in other things also, whenever you go for the digital, first is your security of your data. Because all the things is depend on your data reliability and data accuracy and data predictability. If anybody is changing your data, everything is vanished. So very important and very most important thing is privacy of your data. That there is various things, but this is very important things. Okay, Mr. Akash?
Yes, sir.
Thank you. Anybody else?
Anybody else who wants to ask question?
Sir, then defense using the digital twins, it will be very risky.
Mr. Akash, there's a lot of things we are doing for the security, cyber security, data security, and defense manufacturing, but this is not a platform, and I am not the authorized person who share all the things with you. We are having our own operating system, okay, for this thing also. So maybe that is sufficient for you.
Okay, sir. Okay.
Any more question?
Okay. So once again, I'm here. If you don't have any question, we can conclude the session. And for both of things, I would like to invite Mr. Prem Pandit.
Thank you, sir. So once again, good evening, one and all present here. I, Prem Prakash Pandit, organizing member on behalf of the organizing committee of the 6 days faculty development program on recent advances and applications of manufacturing in Industry 4.0. It is my great honor and privilege to extend a heartfelt vote of thanks to our esteemed keynote speaker, Mr. Rajesh Gupta, sir, Assistant Works Manager, Ordnance Factory, Institute of Learning, Kamaria, Jabalpur, for delivering such an insightful and engaging session on digital twin technology in micromachining. Sir, your presentation has provided us with a deep understanding of how digital twin technology is transforming the field of micromachining by enhancing precision, efficiency, and real-time monitoring. The way you explained this application in predictive maintenance, process optimization, and quality control was truly enlightening. A special thanks to our organizing team, technical support. Most importantly, thank you to our wonderful audience for your active participation and curiosity. Once again, thank you, Mr. Rajesh Gupta, sir, for your valuable time, knowledge, and inspiring words. Thank you all once again.
Thank you, Mr. Prem. I extend my heartfelt gratitude to organizer once again, IPS College, IICT ATAL Academy, and all participants who are with me and making this event possible. Thank you, everyone.
Thank you, Rai sir.
Well,
Thank you, sir. Dear participants, please stay online. Our next session will be started soon. Dear participant, please stay online. Our next session will be started soon. The feedback link will be provided at the end of the session on the chat box. Please fill and submit at the same time. It is compulsory to all participants for attendance purpose, otherwise you will considered as absent. Dear participants, please stay online. Our next session will be started soon. The feedback link will be given at the end of the program. At the end of the today's program, please fill and submit it by same time. Dear participant, please stay online. Our next session will be started soon.
सुशील सर, सुशील सर।
हेलो।
हाँ, सर ने ज्वाइन कर लिया है। उनको होस्ट बना दीजिए, मेक होस्ट। गुड इवनिंग सर।
Good evening, sir.
स्नेहा मैम,
Yes, sir.
आई थिंक वी वुड स्टार्ट।
Okay, okay. Okay, sir. Namaskar, sir.
Namaskar, madam. Namaskar.
Yes. So, good evening, everyone present over here. So now we will proceed for our next session. We are honored to have with us Professor J. Ramkumar, who will be sharing their invaluable insights and expertise throughout the program. Their contribution will undoubtedly enhance our understanding and inspire us to elevate our practice as educators. I invite Professor J. Ramkumar to deliver his talk on sustainability and green manufacturing in Industries 4.0. But before his talk, I would like to take the privilege to introduce our next resource person, Mr. Professor J. Ramkumar. Professor Ramkumar has an illustrious career spanning more than 2 decades in the realms of research, academia, and industry. His remarkable contribution to the development of highly accurate nanomachining processes have played a pivotal role in shaping the cutting-edge defense system of our time. From revolutionary metamaterial for defense technology to advanced machining processes for aerospace and missile components such as those used in the man-portable anti-tank guided missile. Beyond his pioneer work, Professor Ramkumar has been an inspiring mentor, nurturing over 15 successful startups throughout the country. Moreover, during the challenges times of COVID pandemic, he exhibited crucial innovation by creating essential solutions like the Swasa mask and Sanjeevani oxygen concentrator, blessing frontline workers and hospitals nationwide. Professor Ramkumar's dedication to sharing knowledge has been evident through the creation of 12 MOOCs courses with a strategic 5 lakhs views, research reaching an international audience. He has also conducted and organized more than 110 workshops on design thinking, passionately propagating science and research among students, scholars, industrial practitioners, and faculties. With 90 plus patents under his name, 300 plus publications, 5,500 plus citations, and an H index of 40. He has collaborated across communities to bring innovation that impact and foster research innovation across communities. He is a fellow of INAE, IETE, a distinct alumnus of NIT Trichy, and a recipient of 30 plus awards from ISTE, IIT, IETE, IIPE, IEI, Srishti, IIT Kanpur, and others. His illustrious career stands as a testament to his unwavering commitment to excellence and advancement, bringing honor to the field of academia and engineering alike. Now it's time to hear from our resource person, Mr. J. Ramkumar. Professor J. Ramkumar, it's over to you,
Thank
sir.
you. Thank you, madam. So I did not expect my own biodata will be so long. Thank you. Thank you so much.
Thank you, sir.
So good evening, friends. I understand it is a Friday evening. You will all be having a weekend start hangover. So what I will do is I will try to take maybe another 45 minutes to 1 hour, and then end of the session, you are most welcome to ask questions. So during the presentation, I would request you to hold on because then we lose track. In online, the biggest difficulty is having the audience together is the toughest problem. So let me finish my presentation and then let me start getting into the discussion with you. So at the outset, I would like to thank the organization for giving me an opportunity through the FDP course, as well as the Government of India for sponsoring this event in your college. So thank you to everybody, and thanks to everybody for decided to come and attend this session. So thank you to all of you. So now I'll get into the topic, the sustainability of green manufacturing in Industry 4.0. Friends, till now, whatever we have developed, products, processes, right? Processes, all these things, we had only one thing in our mind was we have to mass produce. We were only trying to mass produce. Initially, we were starving for products and process. Later, we started slowly understanding the product and process. We started producing in mass. Then slowly came the customization into effect. Once the customization came into effect, then we started converting ourselves from mass production to batch production. Now in batch production also, we thought it is not getting fully mass customized. So then they said, okay, let us start doing complete mass customization, wherein which the batch size was thought of 1. But throughout the process, which we are talking about 150 years, we have been all the time looking for solution to the problem. Never we gave a damn to sustainability. For example, you take a toothbrush today. Toothbrush today, which you use it, the most important parameter, the most important part of a toothbrush is going to be its bristles. Moment the bristle loses its life, we throw the brush out. But if you see in a brush, there is a plastic handle where you hold it, right? So now the complete plastic handle, which is still in a good intact condition, is also thrown into the dustbin. So what was your objective? Your objective was to brush your teeth. So now, what is the part in a brush which does that brushing? Is the bristles. And this bristles has to be held, right? That's it. So now, what if we think of a solution? You think of your one finger glove which we put. Generally, they wear this one finger glove for vegetable cutting and all. They used to wear one finger glove. It will be only one finger. That finger alone will have a glove. So that will try to feed the vegetable so that when people cut it very fast, the finger does not get damaged. On this one finger glove, if we have bristles intact, attached, so every time what you do is you will try to wear the glove, one finger glove, and the bristles are attached to it. So you brush it, and then after you brush, you remove the glove and then keep it aside. So what is the advantage? The advantage is number of material which is used, number of parts and the amount of material which is used, the volume of material which is used has been drastically brought down. And interestingly, when you think of a brush, when your face and my face, madam's face and my wife's face, my son's face, all are different. But we all use only a very similar brush. So what is the guarantee that it cleans our teeth? There is no guarantee. They say the flexibility is given to the holder or to the hand holding part or to the bristles. But that also does not play a very important role. So now, friends, there is a need which has come for including sustainability in all the products and processes. The vehicle which goes on the road, the typical efficiency of the IC engine or of the petrol or diesel engine, typical max best to best, is around about 40%, right? 40 or 45, let us take. What does that mean? When you pour 1 liter of oil or diesel or petrol, only 40% of it is used for the work, whatever it is. The rest 60% goes as waste. Now that 40% also, you assume you go on a traffic road. So then that 40% falls down to 20%. If you have potholes in the road, that 20% falls down to 15%. So for 1 liter of petrol, whatever you used, you are only using 150 ml of oil or diesel, whatever it is, for the welfare. Okay. Now you see the complete process, whatever we are talking about, does not have sustainability. When you are all young engineers, boys, girls were all getting into the market. Now, sustainability will be a big thought process. So my focus is having sustainability and green manufacturing. Green manufacturing means we have now borrowed the mother earth from the next generation. I put you in my next, you guys are next generation. Let us assume you have borrowed it from the next generation. When you guys give it to the next generation, you should give it in the same fashion that mother earth is still good green for them to live. So now all the manufacturing process which is thought of, we should try to have green, and wherein which industry 4.0 is going to play a very important role in terms of quality, traceability and analysis. So that's what is the entire talk about. So my talk, I have put an outline like this. Say first, I will try to talk about sustainability. Friends, sustainability today is defined in n number of ways. We don't have a sustainability factor. We don't have a sustainability scale. Like in hardness, we have a scale, Morse hardness 1 to 10, right? Like that, we don't have anything which is clearly defined in sustainability. It is evolving. So first, let us see sustainability. And the world today is been working on the sustainable development goals. This is not like 25 years back. Maybe 2000, the world decided, the intellect community decided, let us try to have the sustainability development goals. Why are the sustainability development goals very important for you guys are, you have to try to fit in your product, your process, your thought into that 17 goals only. Today, Government of India has decided that anybody who wants to start a startup has to have at least 5 of the sustainability goals in the product, whatever they said, what they develop, product or process, whatever they develop. Then we will move to Industry 4.0, which is the talk of the town. Then types of manufacturing, smart manufacturing. Then we will try to see green, sustainable manufacturing. I will try to keep a focus on aviation industry because aviation industry is always attraction for young minds. Then challenges and the future direction, how it has to go. Finally, I will try to give some conclusions from my personal experience. Sustainability is, if you see very nicely, sustainability is defined as environment, social and economical. Today, we are trying to talk about the social economical cluster, society. Okay, so social, when we say, it includes natural and built environment. And when we try to talk about economy, it talks about economical development. So here, if you see, there are 3 big pillars. Environment is one pillar, social is one pillar, economy is one pillar. Today, Government of India is pushing very hard to develop socio-economical solutions. Let's take a simple example. There is a boy or a girl who is studying paramedical courses. For example, 10th pass, they do 1 year paramedical course, they become some paramedics. So immediately after their studies, they try to move to urban city. And once they start moving to urban city, they get, because they come here for job. Moment they come here for job, then they settle down at the urban itself. But they started from the rural village, they moved to urban. So now the solution, whatever we do, is not socio-economical. The people have moved from the rural to urban, which puts a lot of pressure on the society, as well as the rural people are still left as rural people only. So the sustainability means protecting environment, protecting social, protecting economy, put together is sustainable development. The development that meets the need of the present without compromising the ability of future generation to meet their own needs is sustainability. It is a balance of the environment, economy, society to create healthy, diverse and resilient world. Sustainability is a social goal for people to coexist on Earth over a long period of time. So now what is happening, as and when we get educated, we move towards urban. So people have started moving towards Delhi, and now Delhi is completely packed. But the rest, you cross Delhi and come 50 kilometers left or right, north or south, whatever it is. So you will see villages and other things are still in the very retained, very backward location. So sustainability means you have to distribute, you have to take, the economy has to be distributed and people have to live in the earth for a longer period of time. Sustainability development requires an integrated approach. It should not be a piecemeal approach, right? Even in student community, what are we trying to talk about nowadays in the new NEP is we are not thinking of route learning. We are not asking the student to do just memorize everything, come and reproduce in the examination, get good marks and get out. Now we feel his overall personality has to grow. We feel his thought process has to grow. His thought process should have socio-economical thought process in him. He should start having innovation skills. He should start appreciating people around him. So this is called as the integrated approach. When we talk about sustainability, you cannot work only on the product or process. Right? So today, when Blinkit tries to give you a item, for example, a lemon you buy, a curd packet you buy, this you buy, that you buy, it is all 10 rupees, maybe 10, 20, 30, 40 rupees. But along with that, they give you a bag which is also worth of 10 rupees or packaging charges they give. That is also fine. Moment you order Blinkit from a nearby shop, there is a guy who sits in a bike and kicks and comes and gives you and go. That fellow produces pollution. Right? So the integrity approach is you don't try to have pollution, but you still try to do a delivery. For example, Ola and Uber, they did it. So what they did was first they said, okay, these are the cars. If you want to pick any of these cars, you can pick. Then they said, okay, if you want to share it, you can share it. It is an integrated approach, wherein which the pollution is reduced, people have their comfort. Right? So these are all sustainability development requires an integrated approach. When you look into sustainability, it has priority models. So priority models are models wherein which these are keeping sustainability as the primary goal of it. So sustainability means we talk about initially reduce, reuse, recycle, refurbish, review, all these things, several R's have come into existence. So now we try to put a priority model for sustainability has to be thought of. Then what we do is we start looking into the sustainability goals. So then we see local to global, differentiation of the global, national, regional, and local level. The Gandhian approach was typically that what Gandhian approach said was they said if you are staying in a village, you establish a school there, you establish a shop there, you establish the rest of the community, whatever it is there in that village, and you live together, you don't diverse, move out of it. So the differentiation of the global, national, and regional and local levels also is very important from the sustainability. Then intergenerational is also there. You are trying to take the third generation, second generation, first generation together. Typically in sustainability, we are looking for inclusive society. So intergenerational understanding and time framing is very important, right? And the last thing is multi-layer approach has to be there. So action on the individual, societal, and the political level should be there. For example, there has to be a political policy. That political policy will be implemented in a society where we are all human beings part of it. Now, the bigger goal is split into smaller goal to society. From a smaller goal, which is split into individuals like you and me. So now we start working. So when you work, society grows. When society works, the overall political or the policy level happens. So that is what is multi-layer approach. It all has to be connected with each other, right? So many a times in your own family, you will see left hand and right hand, what they do, they don't even know. So now it is not so. You take a policy and then start working. So here, when we try to look at the pyramid which is there, from the bottom of the pyramid, it looks for future security, where it ensures the availability of sustainability management for resources for the future. The way in which we are using Mother Earth's resources are very, very high, very exhaustive. So now that has to be stopped. That has to be stopped. So Future security is very important. Then ecological, then it is community empowerment. So community empower means here we are trying to empower we are trying to empower people and we are trying to reduce the inequality. 10-15 years back when I was in Japan, it was very interesting. Japan, the average salary of a male or a female is directly age multiplied by 10,000 yen. Suppose you are a 25-year-old person, 25 into 10,000, you get 2,50,000 yen. Once you become 30, you get so much. Once you become 50, you get that. So what it does is it says as and when you go up the ladder, you go up the ladder. So this will try to reduce the inequality in the human and the opportunity. And the other thing is every individual there, it is respected. For example, a taxi driver at the age of 50, you can say he will earn 5 lakh yen. The barber who is there at the age of 40 will earn 4 lakh yen. So reduced inequality in income and opportunity will be there, thereby which promotes empowerment and equal opportunities for all of them in the society. Ecological balance is also very important. It provides a roadmap for businesses and countries to grow away that adopts the climatic change. So now we are trying to sell carbon footprint this way, that way and all. Then economical prosperity is also very important. And finally, economical prosperity is basically the GDP. Then the biodiversity, we are trying to protect everything and then do it. So these are all part of sustainability we do. This is very clear and this is now talked everywhere, 17 goals which are there. If you see, we have fit in every possible thing is fit in here. So you can take up anything. So education, if you say, education comes in 4. Education comes you can say in sustainability also education comes. Gender equality also education comes. Then you can also talk about partnership with the goal. 17 also education comes. So if you do anything, if you can fit in at least 5 of them of these goals, then you are sure into sustainability. So what are the parts of sustainability? One is people, prosperity, peace, partnership, and planet. So all these things are part of sustainability goal. So it's not talking about prosperity, it's also talking about people and prosperity. Even prosperity means it is not that making peace, a sacrifice on peace, it is prosperity and peace also. And it is not I growing, it is we growing, partnership. And finally, we all grow on the mother planet, so that is planet. So protect our planet, natural resources and climate for future generation. When we look into the SDG progress assessment of the 17 goals, we are, if you see 100%, where are we? So we can see that the green one, on track or target met. You can see goal 17 is met, goal 15, like 30% is met and other things. When we look at the marginal or moderate progress we are having, so this is the moderate progress we are having. So almost everything is getting stuck except goal number 7. If you want to see goal number 7, it is affordability and clean energy. So there we are pushing hard across the globe such that we can try to hit a required output. So the American investors and futurists we are called to be architects of the future, not its victims. So this is what they say in the future. So when we talk about Industry 4.0, Industry 4.0, it started with 1.0, 2.0. In 1784, first industrialization happens. Then second happened in 1870. Then third one in 1970. Fourth one in 2011. And the fifth one in 2020. So the biggest difference started in 1970 is computers, automation, they all came into existence. Electronics also came into existence. 2011, we started talking about cyber physical systems, IoT, networking, and machine learning. Today, we talk about human-robot collaboration. Robots are coming into existence. Human-centric customization, HCI, is also coming into existence. Sustainability, resilient, and manufacturing is also thought about. So this is what I introduced when I said in the first part, it was more of job shop. So the production time was phenomenally large. Then we started having dedicated systems, so wherein which mass production came into existence. Right? In the first one, mechanization happened. In the second one, electrification happened. In the third one, automation and robotization happened. Right? Wherein which in mass customization, we started talking about flexible manufacturing systems, reconfigurable manufacturing, modular concepts came into existence. And then we started talking about machine talking, machine system talking. All these things started. CNC machines came into existence. Then adaptive distribution systems, they also came into existence. So then the last part is globalization. The smart manufacturing system today, what we talk about is we talk about cyber physical production systems. So here we look at cyber physical services, cloud manufacturing. So cloud manufacturing is pretty interesting. People might think, what is so special about it? See, if you have a server at your place, right, and if you want to maintain a server generally they try to maintain somewhere around about 16 degrees Celsius to 18, 19 degrees Celsius. The maintenance of the temperature is important, maintenance of humidity is important, and to maintain 16 to 20, and the variation cannot be more than 1%. If you put all these things into existence, and if you keep running a AC unit or a complete server protection system, it's going to be extremely expensive. Now, the cloud manufacturing and other things, what they are cloud computing, what they are trying to say is you buy a cloud space, you take it on a rental, and then you start using it. Amazon, AWS is also part of it, right? But it is expensive, but in a large extent, it is trying to bring in centrally controlled, so you will have a lot of energy reduction. So then distributed manufacturing, green manufacturing is also coming up today. For example, initial days, I'm talking about 10, 20 years back in Kanpur, when summer comes, I will not get any other vegetable apart from potato, and then I might get some palak. That's it. These are the two items I might get. Aloo, palak, and maybe some bindi I might get. Tomato, I will never get. Tomato, carrot, I will never get. But today, what has happened is round through the year, I get all the fruits, all the vegetables, whatever I want. So what is that? This is distributed manufacturing. So supply chain has come in a big way, and logistics are controlled in a big way. Then green manufacturing is also coming up. So if you see today, the fourth generation where we are all sitting today, it is more of digitization and cybernization. Digitization is not so easy. Let me give you an example of the question paper, whatever you do. See, now what we are trying to talk, Government of India, where I'm also part of a committee, what we are trying to do is we are trying to understand that when a student comes to the examination hall, he has an option of choosing a question paper. For example, if it is theory of machines, in theory of machines, what we want is we wanted to have two questions. So we will have three questions. Three question papers, right? The first one will be easy question paper. The highest mark will be only 70 out of 100. Right? The next paper, next level of paper will be slightly difficult, which you can get maximum 80 marks or 90, 85 marks. The third set of question paper will be tough, wherein which if you attempt that question, you can get 100 out of 100 marks. So what is that? So here completely what we have done is we have given the freedom based upon your preparation. You try to come and take you pick the question paper. The question paper, we will not show it before. You come to the hall for the same exam, 3 question papers will be there. You pick one and go and start solving it. Based upon your answers, questions, they will give the marks. So that is complete digitization of your evaluation, whatever we do, which is tough. It is not so easy. Then comes the cybernation. And while doing so, what happens is, and all the exams will now be online. And now we are also trying to talk about why should there be a classroom learning? Why don't there be peer learning, but at anywhere? So classrooms anywhere and everywhere. So this is also a part of digitization, right? So digitization and cybernation, these are the talk of the town, and this will lead towards Industry 4.0. In the Industry 4.0, all these players are there. If you are a typical mechanical engineering guy, additive manufacturing is one industry which might fascinate you. Additive manufacturing comes up in a very big way. So this additive manufacturing, we add material as and when it is required there. So when you add material as and when it is required here, so then there is a huge saving of is a huge saving is there because subtractive processes are completely different. So additive manufacturing, what we do is we try to add material as and when it is required. We can have combination of materials required, and here start to the end will be done in one step or two steps. Right? And by using additive manufacturing, the number of parts have reduced, the design concepts have fundamentally changed. Right? It has now become a one-shot process. So earlier, the workpiece used to go, or the material used to go several steps. Now in one shot, it has gone. So that is part of Industry 4.0. Then cloud computing, SPS, augmented reality. Augmented reality is coming up in a big way in teaching, learning, in operation, for teaching, learning, in education, in medical field, in dental field. Everywhere augmented reality is coming up in a very big way. Internet of Things is also coming up in a big way. So trying to control things centrally and then doing it. Big data and machine learning and big data analytics is also coming up. Big data analytics is, why is big data talked more today is because computers have generated in the last 10 years. For the generated computer, so much of digitization has happened. So because based upon the digitization and computer development, the power of the computer development, the analysis algorithms have also improved. So we are able to predict what is to be done in the next thing. For example, big data analytics will try to tell you what will be the demand of the dress in the next season and what will be the color expectation, all these things, big data. So the manufacturing company will not produce many of the things which will not attract the common man. So this is also for Industry 4.0. So now when we have all these things attached together in the sustainability goal, so then you will try to move towards a brighter future. So when we talk about manufacturing type, I was talking about mass manufacturing, which was in the past. I'm talking about up to 1970s. It was all mass manufacturing focused on high volume production with economy of sales. So then came lean manufacturing, emphasis on waste reduction and efficiency. Right? Today also, if you see, even the motor pumps which are attached in the field, there are motor pumps which run at 100 horsepower, 10 horsepower, 50 horsepower. So these things are huge. 10, 20, 50 are huge. So this now what we are trying to do is we are trying to understand that, and we are trying to bring in little bit of changes and then start doing it. The waste reduction, it can be practiced in your hostel also. Every day, if you have a typical hostel, boys hostel or a girls hostel, where somewhere around about 400 people are there, every day the bio-organic waste, vegetable waste is around about 100 kgs, right? Is around about, so this is nothing but a cooked food which is wasted. So this, when you talk about lean manufacturing, we are only trying to look at all these things. How will I produce? How will I customize to meet out to the requirements without getting wasted? So the emphasis of waste reduction and efficiency comes in part of lean manufacturing. So now in the lean manufacturing, advancement is smart manufacturing, wherein which we use a lot of digital technology and create flexibility and efficiency of the product system. And then finally, it is green manufacturing, because now that you have understood reduced waste and you are trying to bring in latest technologies, smart manufacturing technologies, then naturally it will lead to green manufacturing, wherein which we integrate environmental considerations into all aspects of production. See, let us take a simple example. Come summer, all of us will be using AC. So AC, what happens? We will try to run an AC plant, AC in our house, typically in a temperature around about 21 degrees to 24 degrees. Our human body temperature is around about 27 to 30 degrees Celsius, somewhere around there, 27 degrees, 28 degrees. So you are reducing it to 21 and then you are trying to live. But this will not give you at that instant, it gives you a little bit of cool, freshness and other things. But in the longer duration, this has an impact on your life. So now what people are trying to say is they are saying that why don't we stop at around about 24 degrees, don't go less than that. So now what has happened? Why is that done? Because the energy can be reduced. So integrated environmental consideration into all aspects of production we try to do, that is part of green manufacturing at every stage. When the machine is produced, we will try to have green manufacturing. When it is getting used, green manufacturing. When it is getting refurbished, green manufacturing. When it is getting scrapped, again green manufacturing. At every step, we follow some green manufacturing techniques such that the environment is protected. So now when we look at smart industries, they work on three things. One is network centric. The other one is manufacturing technology, and the third one is digitization. So when we talk about networking, it is this is servitization, and then we talk about smart products, flexible manufacturing. We talk about smart working and sustainability. So today data is available, then data has to be made contextual, data has to be activated, and data in action. So when you talk about data availability, relevant supply chain and factory informations are collected. Today, today everybody, including me, I buy everything through GPay. So now all the data is stored somewhere. So through that data, they can try to figure out how many times in a month Ram Kumar has bought bread, how many times he has bought curd, when all did he buy curd, in the next month will he buy curd or not. So all these things are data available. Data contextualization is information is combined to reveal deeper insight. So first was data, the second one is information. From the data, what you get is you extract and then you remove all the noise, and then when you try to contextualize, you have a information of data. Data activation is AI and machine learning are adopted to improve the speeding up of the decision. Speeding up of the decision making. See, today, if there is any decision to be made, so I as a human take some time to do it. Even if use a Google map when I'm trying to drive a car, I see three ways I can reach a destination where each of these has its own block in the road, distance traveled, everything. So AI tries to give instantaneously the solution, saying that this is what it is, or it tries to tell you these are the three options, you take a good decision. So data activation is also now part of smart factory. And finally, data in action is data is continuously analyzed, informed action that require little or no human input. For example, you try to attach a pacemaker into your body or something like that. So it keeps on telling you the data of your health, saying that, okay, your heart is now getting weak. When you run, it is getting weak. When you laugh, it is getting strong. When you drink this coffee, it is getting good. You will get, based upon your heart, you can try to tell whether you will get a sleep or not. So all these things is data in action. So now when we talk about smart factories, data is very important. There are data which is available. Try to make the data contextual, try to activate the data, and then try to take the data into action. So in a smart factory ecosystem, you have all these fellows playing a very important role. Artificial intelligence, automation and robotics. Today we are trying to talk about cobots. Cobots is human and robo coexists. They work together in a common space. Then industry, Internet of Things, 3D printing, which we already saw. Machine learning is more and more data, more and more algorithm, you have more and more learning. Digital twin is also coming up in a big way, wherein which we use simulation to find out the best solution and try to get it. So the augmented reality, blockchain, today the certificates are distributed, land documents are distributed by blockchain. Certificates issued in the college is also issued in blockchain. Right? Blockchain is now picking up a lot, and there are a lot of things which come in. Big data is the other thing, wherein which we try to have we try to have a lot of data in the big data. Then cloud connecting is also there. So connecting with cloud, so is sharing of data and other things. When we look at a factory, typically it has 4 levels. It has 7 levels, but now I have just put it into 4 levels. Physical layer is where sensors and actuators are there. Today, friends, though there is a lot of development in the area of sensor, still today we don't have sensors which give reliable, repeatable, and multi sensor output in a short duration of time. Sensors and actuators are there, but still a long way to go. Manufacturing machines or all these things have developed. RFID tag and controls are also there in physical labor. Product line logistics. All these things are physical network where in which you have something. This physical has to be communicated for the next level of analysis. So we try to have networking. So you can have 4G, 5G, 6G, 7G, everything you can try to have wireless communication, Bluetooth, everything. So these are all network layers which are there. The third one is analytical layer, where in which you apply algorithms to analyze the data, what comes from the physical layer. And the last one is going to be the decision layer. So where in which you are trying to take cooperative decisions, resource sharing, optimized solution, all these things are there. So analytical layer, it applies algorithm. So when we talk about cloud, we see these two layers, a network and analytical layer, joining hands to produce the output. Green manufacturing is very important because we try to talk about so many R's which I have mentioned here. The first thing is it tries to say refuse, then they try to say reduce, then they say resell or reuse, right? Refuse, reuse, right? These two are different. Refuse, reduce, reuse, repair if possible. So today we have started at IIT Kanpur something called as a repair cafe. Like you come down here, there are tools, so you come and repair your product and go. Refurbishment is other thing. That's why if you see many of the online purchase, the prices are reduced to a large extent because of the refurbishment, whatever is there. So refurbishment, and then you will have remanufacturing, doing a repurpose. For example, initially it was a towel, now it has become a hand key, or initially it was a sari, now it has become a doormat. It is repurposed. Recycle is something you try to do. Recycling is also energy consuming, so we try to avoid recycling. Then we do recovery. That's what we do on a computer, on a smartphone, on batteries. We recover things, and then we remine. So we try to find out what else we can do. Sustainability machining leads to energy efficiency, environmental friendly, occupation safety and health hazards, waste free, and cost effective. So all these things are part of sustainable manufacturing. So what is sustainability 4.0? Additive manufacturing. So cloud computing, IoT, blockchain. So all these things, whatever we have done, is part of various practice towards sustainability 4.0 implementation. In sustainability, the research trends in sustainability 4.0, you will have smart factories, smart sustainable cities, reduce, reuse, recycle, adoption and implementation, effective product service, transparent systems, improved business and product lifecycle assessment. So the sustainability 4.0 key features are, you have, it has enhanced sustainable manufacturing, pollution control, digitization, transformation potential, and then it also has waste reduction, right? And then here, development of a better product, address climatic change, pollution, address climatic change. Then it says environmental friendly design. So the digitization reshapes the economy and better resource management. Transformation, flexible manufacturing. Today we talk about 4D technologies, where in which you activate the product to move left and right by the external force. So flexible manufacturing system and employee safety is also very important. When we talk about the waste, these are the things which is called waste. So the key technologies which drive sustainability is going to be IoT, AI/ML, CPS, cyber physical systems, additive manufacturing, blockchain, right? Digital twin and digital data analytics. So all these things are technologies by which it drives sustainability. When we talk about aviation industry, which is one of the biggest one, aviation industry major contribution to both global greenhouse gas effect and local air quality issues like noise, particularly particulate matters and ozone formation. So aviation industry contributes very much for the greenhouse effects. The aviation and the global emission now accounts approximately 2 to 3% because of the aviation industry. The noise pollution and the water contamination from de-icing chemicals and fuel spill is also creating a lot of problem. The sector faces mounting regulatory and societal pressure for decarbonization. In 2025, the passenger growth and continued supply chain will happen. So International Air Transport Association 2025 financially outlook the global airline industry released. It predicts passenger number might hit 5.2 billion, up to 6.7% as compared to that of 2024. Despite strong demand, persistent supply chain with restricted airlines, profitability and growth is not is one thing which is very important. So the bottom line is expectably, a record-breaking year of revenue will be 2025. Then while airlines are poised to break records in revenue, profitability remains under pressure. So you should understand, more and more passenger moving through, it does not mean that we have made a fortune or we'll get a fortune due to high operational cost and supply chain. So the rise in passenger traffic, so it is very well given, Middle East and other things, but you should understand that the aviation industry, the aeroplane is one of the most inefficient vehicle which is there in mankind, which people try to use. So 5.2 billion passengers will travel in 2025. Increase of 6.4% will be there. But the efficiency of these processes are less than 5% or 10%. Okay. So because of that, they are no way energy efficient and they are no way sustainable solutions. So the global airline industry, the record-breaking year of revenue, total revenue are expected to surpass 1 trillion mark for the first time ever. 4.4% increase overall the previous year. The profit remains modest despite revenue surge. So is the other model. So a profit of 36.6 billion in 2025 up to 31.5 billion in 2024. So you can see here, the business keeps changing and it is trying to bring in. The revenue not so good profit is there. So cost to increase by 4% in 2025 totally is round about this, and a huge money is maintained. So intense salary pressure, one-off expenses related to the several airline employee strikes in 2024. Sharp increase in maintenance cost is also there. So that makes it a little more expensive. Look at it, the employee cost is increasing. The aircraft ownership is also increasing. So average age of fleet. So you see here, there is a aging fleet. So because of this aging fleet, the inefficiency in the system is increasing. So they need higher fuel burn, and additional capex for unplanned retrofitted of aircrafts is also required. So this, if you see aeroplane, though we say so many things, but it is not a sustainable solution. That's what I wanted to present in front of you. We talk about automobile, but plane is also the same, which is there. So what is the challenges wherein which we are now facing to move into sustainability? Aging fleet, because the average age is already 14.8. So the efficiency are low. Delivery shortfalls. So 30% prediction at this thing is there. Grounded aircrafts, 14% of the aircrafts are parked because it is not a sustainable solution. Ordered backlog. The new aircrafts are very much in demand. Around about 17,000 planes are required. The fuel efficiency stagnation, this remains unchanged between 2023 and 2024. So the efficiency is not increasing. So if you look into it in totality, the overall efficiency of the aviation industry, keeping sustainability, it is very, very poor. So this talks about the crude price, crude oil price and other things. The downward trend in global oil price is already there. The decline in jet fuel price has outpaced the decline in the crude oil. So average is 99. So the oil which is used here, the jet fuel is 99 per dollar, which implies 12% drop in year on year. So 2025, the price will go down to 87 per barrel. So though the price goes down, but because of the other inefficiencies, challenges, this aviation industry is not going to be very good. So the carbon offset and the reduction scheme for international aviation is also there. So here the global market-based carbon offsetting mechanism is also coming up in a big way. The designed to stability international aviation emission is there. So from 36 to we are now going to 55 million tons of CO2 generated at a cost of 540 million, and USD has 1,375 million price ranges are there at this cost. So the green manufacturing in aviation industry is looking for the following: sustainable feedstock. They are looking at sustainability feedstock converted into SAF. Then SAF, sustainability aviation fluid, says SAF is then blended up to 50-50 with the conventional jet fluid. Then the blended SAF is delivered into the aircraft, and the reduction emission related to fuel is also tried. So up to 80% of the reduction in the life cycle emission can be done when green manufacturing in aviation is done. So the reduction in energy, water consumption, waste and carbon emission are the key aspects of aviation industry. So the SAF is a critical importance in the aviation industry of decarbonizing effect. So the costlier than SAF is currently costlier than the jet fuel. SAF could rise to 20 metric ton, which is around about 0.6 of the aviation industry. And finally, add USD of 3.6 billion to the fuel built at 2,500 per ton, it is there. So keeping sustainability, aviation industry is focusing on lightweight, eco-friendly materials. We are looking at recyclable aluminium, bio-based composites, and advanced carbon fiber to reduce the weight of it so that the efficiency can be improved. The composites today has become 50%, aluminium 20%, titanium 15%, steel, which is very heavy, is only 10%, and the others are 5%. So if you look into it, CFRP is used all around the plane, laminates. CFRP with sandwich is used here. Fiber glasses are also used here. So when you keep, so the sustainability manufacturing, now the parts which are used in aviation industry, they're all 3D printed. The number of components are reduced. The design is revived. The testing are going on. So what will happen is that the part size, number of parts will go down. The part assembly will also, size will go down. Overall weight will also go down. So additive manufacturing plays a very, very important role in terms of sustainable manufacturing for aviation industry. So we today talk about circular economy. Circular economy is, we are looking at airport and aviation waste. From there, we are trying to get a sustainable jet fuel. From the sustainable jet fuel, we are trying to get into airport and aviation. So we also have the circular economy is, you can see from here, raw material, part manufacturing, product assembly, distribution, then in service. So then you will have, after in service, you will have reuse, then you will have repair, then you will have repurpose, remanufacturing, and then finally you will have recycle and recover. So this is a create value chain, which is thought of. A closed loop recycling and a circular economy approach is design aircraft with end-to-end life recycling in mind. So that means to say, when one part fails, the entire plane, all the parts must fail, so that you don't plan few parts having a longer life and few parts having a lesser life. Reduce the need of raw material extraction and minimize the waste. So all these things are part of sustainable manufacturability in aviation industry. So when we talk about circular economy, practices in aviation industry, we have upcycling industrial waste. So we also have reduced the use of paper. So electronic aviation bill, electronic boarding passes, iPad, providing iPad and tablet to crew people instead of magazine. Then you onboard and ground waste recycling. So we have all these things. Then we have onboard and ground waste upskilling. Then upskilling hazardous waste. Then recycling hazardous waste. So these are some of the circular economy which are practiced in aviation industry, such that it can give you a huge benefit. So when we look into green supply chain management, so one is green supplier selection, eco design, green management, green inventory management, green transportation, and reverse logistics and end of life strategy. So these are all very important, from the source of eco-friendly raw material to partnering with supplier with whole green practices. So there'll be no bill generation, that it'll all be online, everything will be digitized, and then they get the data. So we are also looking at winglet reduced induced drag components. So we are looking at weaker vortex, and we are trying to redesign the plane itself, keeping sustainability as a goal. So without a winglet, you can see there is a turbulent rotation. A vortex is created. Vortex will lead to inefficiency. Winglet reduces induced drag components. So now what we are trying to do is we are redesigning the plane itself in a way to design for operational efficiency. The eco design principles are also used. Induced designing for reduced drag and lower fuel rates are done. So now all these things are taken into consideration, and new sustainability is brought in aviation industry. Siemens digital twin integration is also a major part. They are trying to integrate the digital twin in a paper mill, in a printing mill, or they are also trying to do a digital twin in the turbine industry, the wind turbine industry. They are also trying to do it in thermal power plants. So Siemens and Microsoft work together in standardizing digital twin definition of language. Tesla gigafactories, which is also a case study, where 50 gigawatts in annual battery production by 2020. 5 lakh Tesla cars powered with renewable energy. Net zero factories are also coming. The Tesla is integrating renewable energy sources such as solar power with advanced robotics to create efficient vehicles. Unilever sustainable packaging. By 2025, all our plastic packaging will be reusable, recyclable, and compactable. This is what is Unilever trying to say. So they have taken the goal of responsible consumption and production. So that's what Unilever sustainability goal goes like. So when we talk about Indian textile industry market size is growing up. Now we are trying to looking forward for a long term with zero freshwater textile manufacturing is the focus which Government of India has given. So the leading textile firms in India have implemented water recycling and AI-based quality control to ensure that sustainability is practiced in India also. So what are the challenges? High initial investment is a big challenge. Lack of skilled labor. As of today, we don't know how is the world going to go. What are we up to? Data security and privacy is also a major concern for us. Resistance to change from the traditional users. These are the challenges which are trying to hamper the sustainability manufacturing in today's world. What are the future direction going to be? The development of AI-powered sustainable assessment framework is going to be there. The policy framework and incentives to encourage green technology. Suppose if somebody buys a green car, so their tax will not be there, or there will be no toll price for green technology cars, something like that. Okay, increased focus on cyber resilient smart system. Bio-based material and degradable alternatives for sustainable production we should think of. There has to be a perfect collaboration between industry, academia, and policymakers to make sustainability 4.0 the talk of the town. So to conclude, sustainability 4.0 presents a transformative approach to achieve environmental and eco and economical sustainability in manufacturing by integrating advanced technologies, the enhancement of operational efficiency, reduced waste, and contribution to greener future is being there. The transition requires collaborative efforts between various stakeholders. today towards a net zero carbon economy, the role of 4.0 plays a very, very important role. With that, thank you very much for your patient listening. I am open for questions, if there is any.
Thank you, sir. Participants, if anybody wants to ask question, please raise hand or you are free to ask.
So in totality, I just took one industry, aviation industry, and what are the things going in aviation industry? How is sustainability thought of, which is still a long way to go, long way to go. And the one of the most inefficient machine which exists, one of the most, is aeroplane. So that's what I thought, let me take aviation industry and talk about sustainability.
Good evening, sir.
Yes, sir.
Sir, my question is, you are telling aviation industry or aircraft itself is a most inefficient machine, I believe. Can you substantiate, sir, a little bit, like in what way it is so inefficient? In terms of only sustainability or in any other aspects?
Everything, sir. Sustainability means you are talking about energy efficiency.
Certainly.
Energy
they are
efficiency
thinking
which
of...
comes, and then you see, for example, if you buy a flight, you have to have spares, and then when you have to have spares, it occupies, and these spares are not so liberally available. This industry is not so competitive like automobile industry, so the prices don't slash very fast, right? And then the other thing is it has its own safety and security reasons, whatever it is. There is not many competitive players in that industry, so cost never comes down.
Okay.
So all these things are sustainable. You are trying to pay more money and then try to have try to buy a vehicle.
Fine. But in the today's world, for fast transportation, we certainly require such things. How come we can balance this?
So what is happening is nowadays, to a large extent, people have started using. See, there are people who go for tourist. You can't stop them. There are people who are go for business. So all those people who go for business, they get connected today online and then they have their meetings.
Fine.
Right. So now what we are trying to say is more and more. See, the demand keeps on increasing. Moment the demand increases, still if you see that there are 17,000 aeroplanes which are booked and waiting.
Correct.
So now there is a huge demand. When there is a huge demand, people keep traveling left and right. So now we have to come out with ways and means how we can do our business or how we can do whatever it is in a digital mode.
Okay, sir.
So see, earlier there used to be boarding pass. Now the boarding pass has become online, or it has become digital. Now they have started DigiYatra. So all these things have reduced the paper usage. They have increased the time where they have reduced the time with which you access to the closest spot. So these are all digital technologies where energy is not spent, but it is moving towards sustainability.
Okay, sir. Fine, sir. Thank you, sir.
See, even you take a 25 paisa and fly. See, you take 25 paisa and go by a car, it does not have an impact because the car is not going against the gravity. But when you take 25 paisa extra and go in a plane, you have to pay everything. You carry your own weight and you have to spend energy for your weight.
Correct. Yes.
So in that way, it is very, very expensive.
Fine.
And it is not that, say, for example, if Indigo runs so many flights, it does not mean they make a profit.
Correct.
So they also have to do a logistic planning and balance the crowd.
Correct.
So those are all things which puts it inefficient.
Right, sir. In terms of environmental pollution and things.
Yes, everything, sir. Everything, it puts you into a bigger this thing.
Correct. Yeah, there's a long way to go, I believe, sir, to really reduce such effects in the environment. It's not a short.
Yes. See, what we are talking about is very, very small.
Yes.
Is what we are today we are talking, we are saying little bit here and there. It is very small.
Right, sir. Thank you, sir.
Right.
Anyone else who wants to ask question?
I think it is Friday evening, so everybody is extremely tired. So
Right, sir.
let us close it here. But madam, I still keep my this thing open. If there are questions, if you can coordinate and send those questions, I will try to give the answers. I have especially taken aviation industry today because not many people talk about aviation. They always talk
Yes,
about
yes.
small things. So I thought in totality, aviation industry I will take. Biofuel are there in automobile, but biofuel in aviation is talk of the town because the combustion has to be very high. So I was just bringing out all those things. Okay, madam. So if there are no more questions, thank you so much for the
Sir,
opportunity.
Sir,
Go
there
ahead,
is
go
a
ahead.
question.
sir, this is Dr. Divakar from Karnataka, sir.
Yeah, please go ahead.
Sir, I am a great fan of you, sir. I will be listening to your YouTube presentation sometimes.
Uh,
Basically, I am a mechanical engineer. Sir,
uh,
I have a question. What about
uh.
this implementing this Industry 4.0 to the Indian scenario, so Indian situation?
Oh, it
See,
is going up, sir. It is going up in a very big way.
it is going up, sir, especially MSME, small scale industries.
Yeah, it is going up. See, today what we are doing, I am working on a project where in which this industry 4.0 we have attached to sensors.
Yes, sir.
Now, one of our project is we are MSMEs and all, they will have only very small number of machines. So
Yes, sir.
for them, what happens is there will be 3, 4 critical machines. If they
Yes, sir.
don't take a proper health monitoring, it conks off. So
Yes,
now
sir.
what we have done is we have started putting the attaching sensors with it. And upfront, we are trying to tell the MSME saying that, boss, your machine is going to go fail shortly. So please take care. So then it gives him an alarm. So he tries to have an alternative machine up, or he tries to find out what is the possible solutions such that he can slowly taper down the production, get the spares, and then he can rise up. So
Yes,
there
yes.
in 4.0 is exhaustively used, sir. We are not only measuring the forces or something, we are measuring the temperature, vibration, we are measuring the sound, everything we are measuring. And the other thing is we are not talking about one machine. We are trying to talk about 4 machines or 5 machines, integrating and trying to suggest the MSME how can his electricity bill can go down.
Uh-huh. Right, sir. Right.
So industry 4.0 is coming up, sir.
Thing is, as you spoke, integrated approach to this sustainability,
Hmm.
the contribution of the small scale industries, somewhere something is missing, sir. That's why I
Yes, yes. See, what I would suggest, sir, since you are a faculty,
yes,
what I
sir.
would suggest is let us all take a oath saying that we will start working on societal related problems wherein which engineering concepts can be thought of.
Yes, sir. Yes, sir.
So
Now
if
ACT has, we have started, sir. ACT connect social connectivity activities. We are doing it, sir.
no. See, all these social connectivity activities are good, sir. We connect, we do NSS, we do NCC, whatever it is we do. But
Yes,
we
sir.
are not trying to bring in engineering there. For example, if you can monitor the water.
Yes, sir.
For example, I will talk to you in one of the districts, right,
Yes, sir.
close to Gorakhpur. In the
Yes, sir.
entire district, what has happened? It is not densely populated, so little scattered. They have installed all the independent bio-friendly toilets. They have
Yes, sir.
installed it. Now the toughest problem is these bio-friendly toilets. There has to be water also. So
Yes,
now
sir.
the toilets are staggered all around the district, around about 5 kilometers away, 3 kilometers away. So every day morning there has to be a water tank lorry which has to go refill everything. And if they go for 5 kilometers, they go there. If they see there is water, it is then they have to come back another 5 kilometers before they go to the other one. So now can we integrate sensors, and these sensors will not only measure and tell us the level, but
Yes, sir.
also it will communicate to a central disk or a dashboard saying
Yes,
that,
sir.
okay, these are the places where it is green level. So accordingly, the water truck which goes around, the tanker lorry which goes around, will plan its path.
Yes, right, sir. Right,
So
sir.
now water quality management, water level management is also there. See, and
Yes,
the
sir.
other way around is we use lot of active technology. For
Yes,
example, moment there is a sensor which is electrified, a sensor which checks the water level, then
yes,
immediately the water is low, it will go activate a pump.
yes, sir.
Now the pump gets activated, so the sensor is electrified. From the electrified, the pump is getting electrified. Can we come up with a passive system like what is there in our Western closet? in our homes. There is a passive system. There is no electricity. The ball goes down, the water flows inside.
Yes, sir. Yes.
So all these things are engineering technology wherein which we should start looking into, and sustainability can be thought of. So very small steps, baby steps you take. I am sure, sir, in the next 10 years with the intelligence level our students are there, we should be able to excel.
Same, sir. Super, sir. Super.
We should be able to excel. So, but the only thing is we have to look for problem statements. Even
Thank you, sir.
I don't have, I will tell you a lot of sensors. I go to a mall, I buy an apple. What is the guarantee the apple is good?
Yes, sir.
I don't have a guarantee. And for a Reliance Fresh, for them, if they lose a customer, it is very costly. I go to Reliance Fresh, I buy an apple if it is rotten. I will tell 10 people Reliance Fresh is apples are rotten. Now I
Like
don't
checking
have
gold, you have to have some sensors and instruments for.
right, no. So then what happens? While growing itself, you should have a sensor to assess
Yes.
it. So now if you see many things are there. And see, there are a lot of things which we can do, sir. So
Yes, sir. Thank you, sir.
sustainability has to be thought of.
Right, sir. Thank you so much, sir. Thank you so much.
Yes.
Kind of, sir. Kind of, sir. Bye-bye.
Thank you. Right.
Thank you. I think there is no more questions. So we are concluding the session, sir. Yeah.
Thank you, madam.
Thank you, sir, for your detailed information. Now I invite Mr. R.P. Singh from Department of Mechanical Engineering to propose vote of thanks.
Thank you, madam. Once again, a good evening to all present over here. I, R.P. Singh, Associate Professor, Department of Mechanical Engineering, IPS College of Technology and Management, Gwalior, on the behalf of organizing committee, would like to thanks for Dr. Professor J. Ramkumar, IIT Kanpur, for his valuable insight during this FDP. He certainly explained very well the very good topic regarding the sustainability and green manufacturing in this FDP program. Indeed, it's the need of the hour to protect our motherland for future generations. Yes, technologically going ahead, development is necessity and must, but to protect these resources for our future generation is certainly the more important. So on the behalf of the organizing secretary, I once again congratulate to Dr. J. Ramkumar sir for providing such a valuable insight, and certainly that will be very beneficial for all of us. I also congratulate the audience for remain engaging during the time of sessions. So once again, we would like to thanks to all, from organizing secretary to the speaker and to the audience from the behalf of the college. Thank you very much, sir. Thank you.
Thank you, sir.
Thank you, sir.
And thank you so much, sir, for giving your time.
Thank you, sir.
Thank you, sir.
Thank you, sir. Yeah. Bye, sir. Good night.
Good night, sir.
Good night, sir. Good night.
Now, dear participants, the feedback link has been given in the chat box. Please fill and submit it right now. I request to all, you may leave the room, but after submitting the feedback. All participants, please fill and submit the feedback form. After that, you can leave the room. And our next session will be started tomorrow at 2 p.m. Please join. I request please join 10 minutes back.
हेलो मैडम,
Yes, sir.
ये कल फीडबैक फॉर्म नहीं लिंक आई थी कल?
Sir, it was given in only in chat box.
ओके ओके,
आपने सबमिट नहीं किया क्या?
नहीं हम वहां पर देख रहे थे व्हाट्सएप पे, तो दिख ही नहीं रही थी वो लिंक.
Okay.
Actually, feedback link will not be pasted in the WhatsApp group.
अच्छा अच्छा, तो अभी इसमें चेक बॉक्स में मिल जाएगी ना अभी इसमें?
Yes, yes. It is there, sir.
अभी chat box में है.
ठीक ठीक ठीक.
All the participants are requested to fill the feedback right now. This link will not be pasted in the WhatsApp group.
It is requested to all. Please fill and submit the feedback. Yes.
मैम कल इसकी कोई इंफॉर्मेशन भी नहीं आई थी कि गूगल फॉर्म आपने फीडबैक फॉर्म आपने चैट बॉक्स पे दिया है या व्हाट्सएप पे नहीं आएगा
No,
अभी तक
there
क्योंकि
was
रेगुलरली व्हाट्सएप पे आता था
Actually,
That's
I was informed. I was informed in the meeting more than 2-3 times. I've
Madam, myself
informed.
also I was waiting for WhatsApp message.
मे बी उस समय ना
He
मे बी उस
writing
समय ना सुन नहीं
Google.
पाए होंगे लेकिन ना उस पे व्हाट्सएप पे अगर मैसेज आ जाता ना तो फिर वो अटेंशन चला जाता वहां पर
Okay, okay.
If you can kindly permit us for yesterday's feedback also, we'll do it, madam. Or else if it is okay, no problem, madam.
Okay.
Thank
Sir,
you.
please fill for today. I request to all, please fill and submit the feedback. After that, you can leave the meeting. And please keep in mind that tomorrow session will be started at 2 p.m. So please join 10 minutes prior.
Okay, madam. Thank you.
Yes, sir.